Welcome to our introduction to Jenkins. Jenkins is an open-source automation server, a powerful tool designed to automate various stages of the software development process. This includes tasks such as building code, comprehensive testing, and deploying applications. It is most widely recognized and utilized for implementing robust SIST, or continuous integration and continuous delivery, pipelines. Let's delve into the key features of Jenkins, starting with continuous integration and continuous delivery. Jenkins automates this crucial process by continuously pulling code from your repositories, such as Git. It then proceeds to build and thoroughly test the code, and if all tests pass successfully, it automatically deploys the application. This streamlined approach ensures a consistent and rapid development cycle. Another cornerstone of Jenkins is its extensive plugin ecosystem. With over 1,000 available plugins, Jenkins offers seamless integration with a vast array of popular development tools. This includes systems like GitHub and GitLab for version control, Docker and Kubernetes for containerization and orchestration, and build tools such as Maven and Gradle. Moving on to our next key feature, Jenkins supports pipeline as code. By utilizing a Jenkins file, you can define your entire SIST pipeline directly within your code. This offers significant advantages. Your pipeline becomes version controlled, fully reproducible, and remarkably easy to modify and maintain, just like any other part of your codebase. Jenkins also excels in distributed builds. It has the capability to run build processes across multiple machines, known as agents, significantly improving both build speed and scalability for larger projects. Furthermore, Jenkins provides easy monitoring and reporting functionalities, offering detailed build history, comprehensive test reports, and granular logs for efficient debugging. Security and access control are paramount in any development environment, and Jenkins addresses this through features like user roles. It also supports integration with various authentication systems, such as LDAP and OAuth, ensuring that access to your pipelines and resources is well governed and secure. Now, let's look at the flow of automated builds and testing. When code is pushed to your GitHub repository, Jenkins automatically triggers a build process. During this build, Jenkins runs both unit tests and integration tests. The ultimate output is a clear build success or failure report, providing immediate feedback on the code's quality. Next, let's introduce Ansible. What is Ansible? It's an open-source configuration management tool, widely used for various IT automation tasks. Its primary applications include server setup, ensuring consistent environments, and deployment automation for applications. A key feature that sets Ansible apart is its agentless architecture, meaning no special software needs to be installed on the client servers it manages. To understand Ansible, let's cover some basics. First, the inventory, which is essentially a list of all the servers Ansible will manage. Then, the playbook, a YAML file that defines a series of tasks Ansible needs to execute. Finally, modules, which are predefined actions within Ansible, like copying files, installing software packages, or starting a service. Now, let's see how we can use these tools for automating deployment. The process involves three main steps. First, Jenkins builds your application, generating an artifact like a jar or WAR file. Second, this artifact is prepared for deployment. And third, Ansible takes over to deploy this artifact to your designated server. Integrating Jenkins and Ansible creates a powerful synergy for a fully automated SIST pipeline. The typical flow involves code push to Git, which triggers Jenkins. Jenkins then builds the code, produces an artifact, which is then handed off to Ansible for server deployment. The major benefit here is a completely automated SIST pipeline, from code commit to production deployment. Let's walk through the practical steps. Starting with step 1, how to start Jenkins. You'll open your browser and navigate to localhost 8080. Upon first access, you'll need to unlock Jenkins using the provided admin password. After that, it's recommended to install the suggested plugins to get a fully functional environment. Step 2 involves creating a sample project. You can do this using either Maven, by running mvn archetype generate, or Gradle, with Gradle in it. After initializing your project, you'll want to add some simple Java code and a basic test case to work with. For step 3, you'll push your code to GitHub. This involves initializing a Git repository, adding your files, committing your initial changes, and then pushing your code to a specified branch and remote repository. The commands are listed for your reference. Step 4, create a Jenkins job. Navigate to your Jenkins dashboard, then click on New Item. You'll then enter a name for your job and select Freestyle Project as the job type. Finally, click OK to proceed. In step 5, you'll configure your Git repository within the Jenkins job. Go to the source code management section, select Git, and then enter the URL of your repository. This tells Jenkins where to pull your source code from. Step 6 focuses on configuring the build tool. If you're using Maven, navigate to the build section, select Invoke top-level Maven targets, and enter Clean Install. For Gradle projects, You'll select Invoke Gradle script and enter build. Step 7 is about configuring the build trigger for continuous integration. You have two main options. You can enable poll SCM and set it to check for changes every minute using the 5* syntax, or, the recommended approach, enable a GitHub webhook, which provides immediate triggers upon code pushes. Once configured, step 8 is to run the build. Simply click Build Now on your job page. After the build starts, you can check the console output to see the build logs in real time and monitor the build status to determine if it was a success or a failure. For step 9, automated testing. Maven and Gradle automatically run tests during their respective MVN test or Gradle test phases, often included within the install or build commands. You can verify the test results by examining the console output or by reviewing the dedicated test reports generated by Jenkins. Finally, Step 10. Verify the C pipeline. Your integrated flow should now function seamlessly. A code push triggers Jenkins, which then proceeds to build the application, execute tests, and present the final result. This completes the continuous integration cycle.